this is something about the planets. So if this is the sun and this is the elliptical orbit, in elliptical orbits, like this is the sun here and the planet is moving here, so there is a time when the distance between the sun and the planet is shortest. So that's the closest point. When planet is very close to the sun, it's moving really fast, or any planet to any of its star in the universe. When it's close to its star or any satellite to its planet, it's close to its orbiting object, it moves fast. And when it's far away, it moves slow. So it covers equal area in equal time. That's the Kepler's second law of area, that if it's close, it will move fast and cover larger area. When it's slow, it will move slow and it will cover the same amount of area like this. So this is the law of area. So now when it is close to the sun, it's moving with the maximum speed. And when it's moving with the maximum speed, then we need to find its calculate the distance between the sun and Saturn. So the potential energy, the gravitational potential energy EP is minus G mass of sun, mass of Saturn, divided by distance between the center of sun and Saturn. Okay, R. That's need to be found. We are given the elastic gravitational potential energy. So R become minus G mass of sun, mass of Saturn, divided by EP. So minus 6.67 times 10 to the power minus 11. Mass of sun is here in this case 1.99 into 10 to the power 30, and mass of Saturn is 5.68 into 10 to the power 26, divided by potential energy, which is minus 5.57 into 10 to the power 34. So minus and minus will cancel out, and we need to multiply 6.67 multiply by 1.99 multiply by 5.68 divided by 5.57. 1.3535 into 10 to the power 12 meter. So the distance between the Saturn and the sun is 1.35 into 10 to the power 12 meter. Now the next question, the next portion of this question is, after 1 year on the Earth, not the Saturn year, because Earth is somewhere here and Saturn is here. So it means that the orbiter, the year of the Earth is smaller than the year of Saturn, because we just proved that in the previous, from t square is proportional to r cube, this relation. So he says that now 1 year has passed on the Earth. What will be the speed of the Saturn? What? No, we don't need to find the speed, we just need to tell, will the speed of Saturn be higher or lower than its speed as in A part after 1 year, 1 Earth year, we can say. So that's what they are asking us. Yeah. So because 1 year has passed, but the year has passed on the Earth, so Saturn, if 1 Saturn year is passed, Saturn will again reach at this point. The closest a planet to a star, the highest its speed is. Any place other than this, the speed of planet will be lower than this point. So because The Saturn after 1 Earth year is not closest to the Sun, therefore its speed will be lower. Okay, so because it's not closest to the Sun, it's not 1 Saturn year, it's 1 Earth year. Yes, if it's 1 Saturn year, then it will be again at the same point and it will have the maximum speed. Okay, so that was it. And the next